Hello and welcome to today's stream. Data and API show here. Adron, your host. I've been out a few episodes, but hey, I'm back to bring you some cool tidbits here on .NET Serverless Functions and Hasura and how you can bring those things together within Azure to do more with them. And of course, you could take the examples that I'm going to show you today and extrapolate them for other cloud providers also. But we'll be focusing today on Azure specifically. And also I want to make a mention here. Where is it? Here it is. It's over here. This GraphQL and data mesh. We're going to be talking about that at the Enterprise GraphQL conference coming up real soon on October 28th. It is a free conference. A few of the tidbits that we will be talking about at the conference, things that we'll be getting into. If you're not familiar with what a data mesh is, it's kind of how you build an overarching plan around your data within an enterprise for access to that data and a lot of the other things too, like audit, security. It's not just specifically about any tactical parts. It's more of the larger strategic picture. And there's a lot of conversations going on around that. So that's going to be some of the key conversations along with a lot of the tactical things that you need in an enterprise data solution, whatever you might have that you're working on. So that's something important to check out in the coming days here. You can register now out there at hasura.io/enterprise GraphQL, or you can go to hasura.io and navigate around and find it wherever it may be. So that is that. Oh, and look, you get a little snippet of what we're going to talk about here in just a second. So let's talk about the overarching picture here. Azure Functions are a way to basically pay for compute execution of processing. And we're going to take a look at that. And we're going to take a look at Hasura deployed out to Azure and it working in conjunction with a particular Azure function, HTTP function specifically, an HTTP handler that's going to take trigger elements, things coming in, requests, and provide responses. And I'm going to show you how you can use Hasura to interact with that. Now, just getting started here. Oh, there's my beautiful blue screen. Let me find, where did I put it? Here we go. So I've got a few things working already, and we're going to kind of go through that. So I have a few key pieces that are already set up that you would have to have in order to work through these things. One is an Azure account, of course, and you would need your cloud provider account to deploy anything to a cloud provider, obviously. So I have that set up. I also have the Azure CLI, which is the command line interface for interacting with Azure. I have this plugin here that is installed. Whoops. I'm just hovering over the button here on the left, which is the Azure Functions plugin for Visual Studio Code, which gives you the ability to do a whole bunch of different things. As you can see here, I'm actually in this resource groups section. I'm looking at active assets out in the cloud that I have. Okay. There's a help and feedback section, which I'm going to actually drag down here because we don't need any help or feedback at the moment. Then here's my functions in my pay-as-you-go subscription in Azure, where I have zgraphin GraphQL server, and then the functions that calls. And this gives you things like execute function now, different options to check that out. It gives you the function URL, which would be the actual public function URL that's out in Azure, and then application settings and some other elements here. So this is a very useful plugin when working with functions. And also here below that is the local project, which we're going to look at right now and take a dive into what is going on with our Azure function service. So, okay, that's a little tour of the plugin. We'll work with that a little bit in a few minutes. Here is the project that is actually out there running in Azure right now, and we're gonna redeploy it again just for good measure. But also, I want to show you where I got this thing from. So let's see if I got that up at the moment. It is a sample. I'll show you the. I'll get you the repo in a few minutes. Right now, we're just going to focus on this right here. So in this project is the Azure function. We have some hidden directories: VS Code, GitHub. VS Code is a folder that's added whenever you create a project for an Azure function. Then we got dist, which is unrelated at the moment to what we're doing or what I'm trying to explain. But here is the GraphQL. We got the function.json for the deployment of this thing, right? And here you can see the script file where the function is going to be. Okay, it's a type, HTTP trigger type, auth level, anonymous. So anybody can get into it and issue a get or post action against the endpoint, and then they'll get whatever the respective response is, which is written up here in this TypeScript file. So it says import Apollo Server GQL, and then here is our type definition. Here is our resolver, right? And then we have a CORS so that we can make requests across, etc. And then here is the Apollo server that is running at the Azure function location endpoint. Now, this is a pretty straightforward, hello world type example. You've probably seen this if you've ever looked up Apollo server or anything like that. This is just an example of what could be happening over here in this Azure function. You could put effectively anything in there. You can write an Azure function in TypeScript, as has been done here. You can write it in Go. I've recently done some live streams on my own personal channel just around using Go, around using C#, things like that to create functions. Now, each of these, we have GraphQL, then we have media, which is just a picture there for a preview. And then we have one more GraphQL function here. There is the binding endpoint data and information there. And again, there's the script file that has the actual functional code. And in here we have our type definition, etc., where there's a query, mutation, etc. around, what is this again? I believe it's like messages for users. That's what it is. And there you can see the database, type definitions. There's the message class, and then the resolvers, the mutation, query, etc. Now, this is a great example to work from if you're building your own GraphQL server, or you're trying to sling some code, or you have one of these running already, like I have right now. And, it's great, because there's always situations where things might come up and you want to write some type of custom code in a function to have some type of thing executing and then pay only for the compute time that thing is executing within the cloud. Pretty awesome capability. And of course, this is the impetus of serverless tech with Azure Functions, right? A few other little things. Because this is a Node.js project, we have our node modules directory. Func ignore is an ignore file for the function. So these bits aren't deployed when we do a deployment. We have a change log, which is just a manually created change log. Contributing, or is it a manually? Just notice this looks like it's built for inserting stuff. It's not used at the time. We have a contributing markdown file, which talks a lot about this project and how it was created and why it was created and what type of reference information it's providing. Here's our host information. This is an important file for Azure Functions. Basically tells you the function bundle information and sets up the application insights. Application insights, which we'll also look at in just a minute, does monitoring and gives you some initial starting points to set up things like observability and such into your Azure function and the action or events that it would be taking once you get that up and running. MIT license, so you can use this all you want. And then local settings.json, package lock, and package.json are all Node.js and local project related. And then, of course, the tsconfig.json. So this is basically your function. This is the whole thing. We got basically this file, and then we have the message file. That's it. That's all the code for the Azure function, and all that is needed really to get up and running from the code perspective. There's, of course, the JSON function that points to and maps over to where the file is to tell the function where these endpoints need to be accessed. Because once this is deployed, if we click here, and then we go to here, the way you can do this, and this is basically doing a deployment, right? So I'm going to set up another one, and I'll do advanced so we can walk through this. This is another example deployed function, right? So that, and then I'm using Node.js 14. As you can see, here's the other things: Core 3.1, .NET 5, Python 3.9, 3.8, 3.7, 3.6, standard Python scenario where there's a million versions, Java 8, Java 11, PowerShell 7, and custom handler. If you write something like Go or Rust and would like to deploy that, you can. You would just use a custom handler to define and point the endpoints and do whatever else you need to do there. There's more documentation out on the web. Microsoft's done a pretty solid job. The team there has really kicked some ass getting documentation built around all of these things. But we're using 14 LTS of Node.js, so that's easy. I'm going to use Linux. I think that's what I previously used, whatever the case. I'm going to create a new resource group. So over here in the active resource groups, that'll show up here in just a second. I could select an existing one if I wanted to, but let's create a new one just to do that. And I'll use the name that it defaulted with. Another example, deployed fun, even though that was supposed to be function. And then I always use US2, West US2, because that's closest to me. And then I'm going to pick the consumption plan. That's how the billing and other various things, along with the active state of the function itself, is set up. So there we go, consumption. And then the storage account. Again, I could use one of the existing ones that I have, but I'm going to actually use create new storage account, and we'll name it that. And then here is the insights, like I was talking about from that one config file, which shows the monitoring and gives you some beginning hooks for observability, etc. But I'm going to create a new application insights resource. There we go. And now it is deploying that app, rolling up all this whole Node.js project and TypeScript Node.js project, I should detail, and getting it shipped out to Azure right now as we speak. Azure will then roll it up and put it on the machine as necessary. So as that works, sometimes this might take 10 seconds, sometimes it might take a minute, sometimes it might take 5 minutes. It kind of depends on the project, the type of project, the language stack, and other criteria like that. Because there's a lot of in the background stuff going on. Like if you do a Linux deployment like I just did, it actually puts all the key files together, zips it up, ships it over to the container, and then unzips it and does some other magical things in the background that you don't even have to deal with. And then it's deployed. It's there. Boom. Okay. You have it. It's available to call the action against the various endpoints that you have. Oh, there we go. So it finished. Here is the URL that we would take actions against. Of course, with the /API/GraphQL or /API/message endpoints that we looked at in the configs just a minute ago. And based on that, I'm going to actually close the local project. Or well, let's look at this real quick. So you can test locally before you even deploy like I did by right-clicking here, execute function now. It's going to prompt you up here, as Visual Studio Code does, ask for the name Azure, and then boom, it's going to send this. And oh, it's not running locally because I didn't actually start it. Let's do that real quick. We'll talk about running things locally. Func start. There we go. Now let's try that again. We can do it this way, right? But what I actually like to do is go open up Postman, right? and execute this call in here. Let's create a new call. And then the other thing you do is right click. There's the execute function now, which executes it right here in line. But I like to really dig into this with Postman. I copy the function URL. Then over here, I can paste it in and then kind of work with it a little bit more, right? So that's what we're trying to do. And if I send that request, I'm going to get nothing because we're not actually sending the GraphQL query. Okay, and that would be this. Was that what we're sending? Yeah, here's the endpoint. Oh, I already had the whole thing in there. There we go. It query is missing. Oh, it's not. Oh, yeah, it is. So I'm trying to send GraphQL, but I have it set to get, and to send that, I actually need to do a post, which is how you make a GraphQL request. So there's our post. That's what we expected. So data is returned. There's our hello world from this locally running Azure function, right? So that's all cool. Let me close that one down. We have seen it working. And I'm going to go ahead and Control-C and knock that one out. Online. Oh, Aubrey31, you asked if it was an online conference, the thing I was talking about at the very beginning of this show. Yes, it's an online conference. So definitely check it out. You can sign up and attend remotely wherever you may be. Internet access is the only thing required. All right. So previously I had deployed this, as we just looked, out to Graphene GraphQL server. Okay, so that's out there in Azure. Let's see here. I have it here. We can actually take a look via the Azure dashboard. So this is the portal.azure.com, blah, 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 URL, which lets you get into your dashboard. Usually when you log in here, you'd see something maybe like this. And what I do is I always click here and then go look at resource groups. And that's the resource groups that we have. I just deployed this one right here with all of you. Another example deployed fun, which I misspelled. If I click that, it'll bring up all the assets within that resource group, or I should say all of the resources within that resource group. Here is the function itself. Here are the application insights running. Here's the storage account and the app service plan. Let's look at the function. All right, here we can get some immediate stats that are pretty useful, at least to know if you have any activity or whatnot. So here's our function execution count, our memory working set in megabytes per millisecond. Also, the URL, right, where actions would be called against. We have the operating system, Linux, right here. Okay, it is running. It's in West US 2. It's on the pay-as-you-go subscription plan based on subscription ID, blah, 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 etc. So a lot of useful information about that particular function. Now going back into that, if I go to the insights, we'll see some more of the options that you see in here. So there's server requests, availability, failed requests, server response time. So some metrics around that from a basic level. And you can look at, 30 minutes, 7 days, whatever it might be. We're going to do 30 minutes, and then let's make some requests. Let's see if we can do that. I'm going to open Postman back up, and we're going to go here, Graphene. Oh, that's that one. Let's actually go look at that specific resource group. I'm going to delete the one that I just created. Basically, we went through the steps exactly that I did with the other resource group we are going to go look at. So let me just delete this real quick. One of the cool things about this is if you delete a resource group, you delete all the stuff in it. So that's cool, but also scary, right? Be sure to note that when you are using Azure, that if you delete a resource group, you're going to nuke the stuff in the resource group. Anyway, that is going to town now, doing its deletion. I'm going to go back over to ZGraphical server. And there's my function. And here's my application insights. I'm going to let that come up. All right, there we go. So we can see stuff. Oh, it's look, it's using some memory. Very, very small amount of memory. 80, almost 120 megabytes of memory. And nothing going on here. No execution count. Over in this section, we're going to bounce to 30 minutes. Just because I think it'll show more readily once we start hitting it. And then go back over to Postman. And there you go, ZGraphing GraphQL server, as you can see. And I believe if I send that, I should, yep. Let's just send some stuff real quick. There we go. Send it, oh yeah, I don't want to download. Now if we go back over here and refresh, we might actually see some ticks pop up. Oh, not yet. It always takes a minute. It's delayed by like 30 seconds to a minute. Come look at that in a minute. But okay, so we have that running. And as I showed, the ZGraphing GraphQL server is a GraphQL server that basically gives us a hello world and there's a message prompt. So that's great. Now imagine that this is a GraphQL server that does whatever else you need it to do, you know, a whole bunch of functionality. And then you decide, okay, we're going to deploy Hasura out to the Azure cloud. And then we want to be able to use the Hasura API as the gateway. We want that to be the primary access point in which people access their GraphQL requests, mutations, subscriptions, etc. Whatever it is that comes up that they need. We can do that. We can do that very easily. And I'm going to show you how right now. All right, so all that is running. And while we're at it, there is another resource group that I've called Graphing Group that has an actual Hasura instance deployed. And I'm going to show you how I set that up right now. But I just wanted to show you before we dive into the code, there is the Postgres server. Here's the Hasura API server instance running. Here's the fully qualified domain name. Here's some of the CPU activity, memory, which is only at 140 megabytes. So an entire API server that points at the entire database, Postgres database, and it's only using 140 megabytes so far. So that's an excellent starting point. It's using barely any more memory than an Azure function. So pretty great asset to have in that sense. They're also both technically running in containers. So in the background there is some Kubernetes magic going on because this is running in ACI, Azure container instances, and Azure functions generally run in containers also. But we don't particularly, we're not informed that they're Kubernetes or anything in particular. We would just know those things if we happen to know the architecture, which I may know about. All right, so I'm going to bounce out of that. We got our Postman right here, but I'm going to also, okay, it's running. That's all great. There's our code. Minimize that. Whoops. Minimize that, and then minimize this. And then I'm going to bring in, here we go, another project. Now, one of the things I did with this project, just to show how it could be organized, let's say you have an Azure function. In the Azure function, you're going to write in your custom stuff, whatever it might be. Maybe you're going to make it a GraphQL endpoint. Maybe you're just going to have it be called from the backend. You know, there's a million ways to implement it and implement what you need specifically for this situation. Or I should say your situation in your enterprise, your company, your organization, whatever it is that you're doing work for. In this, I have several key files. I should say key sections. This is a local function project to start with. I'm using a tool called JetBrains Writer. So if you're using Visual Studio, like the full-blown Windows proprietary C#, F# dev environment for .NET Visual Studio, you can set this up exactly like this because it opens up projects within solutions or solutions with many projects, however you want to do that. This is just a project, no solution file. Then there's also Visual Studio Code. You could also look at it from that perspective, but I'm using JetBrains Writer to kind of give a mix. This is somewhere in between like full-blown Visual Studio and Visual Studio Code. It's independent. It's a JetBrains product. It's not a Microsoft product. So it's a little bit different. It provides a little bit of different functionality and features in a different way than some of the other IDEs. But the key here is I created this local function project via the .NET CLI, or I should say the Azure Functions CLI. And then in that, it gives you dependencies, which maps to the things that a C# project would need, in this case, .NET Core App 3.1, to build out functions in C#. Okay. Now I don't have this running out on the cloud right now because we're going to use the other Node.js TypeScript project. But I wanted to show that this project is a function project in itself. This is the function and how one would look in C#. Okay. So if you have a project like this, you can build out your whole function project and then just stick your Hasura infrastructure and everything right here in a directory as I've done. Now I also have Terraform set up to do the deployment of this Hasura environment out to Azure. Okay, and I've broken it out in this repo, which I will make public right here at the tail end of the show, where I have the breakout of main servers, Hasura API, firewalls, and databases so that you have all the pieces of Azure needed in Terraform to be able to deploy it out to Azure and have a whole Hasura API up and running. Now, the commands I put together in the build sh file. I pass in a few variables, the server name that I want. I get an environment variable for username and password. So that's a local environment variable. You'd have to set those up if you were going to do this yourself on your own machine or your own Bastion server to deploy this. And then API port, because I like to pick the API port that the console is going to be active on. And then I auto approve this so that it can just deploy it when it's already done its scan of what's existing state versus what it expects to deploy. And then once all that's deployed, I use the Hasura CLI to do a migration of the database schema, apply the seeds, which put the initial values in the rows, and then apply the metadata so that the Hasura server knows about the underlying database and all the things that have just been put in it. And then I go ahead and launch the console so that we can look at that based on the Terraform execution. All this just in the build sh, bash script or just a script, whatever you want to call it, in the script file, so you can just execute it, and then it'll pop up the Hasura console as soon as everything's up and running. Now, looking at the Terraform real quick, just to get an idea, here is the provider, which just states that it's running against Azure, the initial resource group that is built for this specifically. Then we have a storage account too that is needed, the respective variables, and then I have an output variable, which basically serves one purpose. It doesn't even need to be there functionally, but I like to have it because then I don't have to go back into the portal to get the URL to map to the console in case I want to manually run Hasura console or just manually open up a browser and then go to the console. Here we have the GraphQL server, which is the database server. Okay, the Postgres database server version 11. Then we have the database on that server, the Graphen database. Okay, and then we have a firewall that's opened up on the Postgres database service that opens up between the ACI, Azure Container Instances, which is where the Hasura API server goes. It opens up the ports, or I should say the IPs. It opens up the firewall between it and the database so that it can connect to the database and be the public-facing part of the database. And then finally, the Hasura server itself. We have the Hasura GraphQL database URL, which is concatenated together through various interpolation. Here's where I set the API port, designate which version of Hasura is going to be pulled from Docker Hub, or I should say Hub, or wherever it would be being pulled from. Designate half a CPU, 1.5 of memory, and then it launches. It has a public IP address so that we can go to it, and you watching right now could also go to it. And then location is based on the resource group on down through the respective features. All right. So all that's there, all that's available, all that will be easy to download as a reference example. So in here, let's do this. Then I'm going to navigate into, oh, I'm in infrastructure already. So if I run build, we're going to launch this, and it should go through, build out the resources. And if it's like partially put together already to build the resources that are needed, in this case, as you can see, apply complete, nothing needed to get built. It tried to reapply the seeds to a database that already exists. So it didn't do certain things there, but that's okay because it would just make redundant data if it did that. And that's what a primary key is supposed to do, is prevent you from inserting things that shouldn't be redundant. So the metadata has been applied, and then our console should be popping up in just a second. And if it doesn't, I'll just do this, and then Hasura console. And this is our next awesome point. All right, so here is our database, okay? If we click on the data tab and stroll over here to our actual database, you can see I have a public schema, which is the default one that comes in the Postgres database right out of the box. And then I have a bike schema, which is what the migrations have put together for me. In the bikes schema, I have brands with some data, which was inserted by the seeds, the Hasura CLI seeds, for all cities, Surly, Dahone, Oyama, Tarn, and Brompton bikes. Then models, the Big Block, Space Horse GRX, Ogre, Midnight Special, etc. And then types of bikes, road bike, mountain bike, touring bike, folding bike, etc. And all of these things have their respective relationships drawn here like this. You can review each of those. For example, the models, you can pull the brand or the type with the model when you do your GraphQL queries, which we'll look at API over here. And then let's look at models. And then we'll get the model, do the description, create it at, and then let's get the type. There's the type. And then, there we go, brand. Get the brand name, and then let's run that. And what do we get? There we go. So here's a model, and it shows the type, the brand, and all of the other pertinent information that we asked for in our GraphQL query right here. Now, this is great. Okay, we have Hasura. We got it pointed at the database, all running in Azure right now through execution of that one script with the respective Terraform. Fairly straightforward process, something that you can pull and use to deploy your own environment if you would so like. Just a few tweaks that you would need to make, like setting up the environment variables and making sure that you have the Azure CLI, Terraform, and an Azure account set up. Those are your main things that you need to set up. Now, the function that I deployed earlier, though, that we deployed via Visual Studio Code is out there running, right? Now, the way that you would bring that in so that everybody can access this via here, via the console or via the Hasura GraphQL API itself, would be to go over to remote schemas like this, and then you just click add. Here you can give it a name, some name of another GraphQL endpoint, and then you would put in the endpoint here, which would be HTTPS, whatever the endpoint would be, like that. And then you would add the remote schema. I'm not going to click that because I have already added the GraphQL Azure function that we have. So here is the actual endpoint, and we ran a request against it via Postman just a minute ago. So zgraphin GraphQL server.azurewebsites.net/API/GraphQL we know is active. We sent a query against it. We got a response. You can also, however, there's all your settings, and you can set up your permissions if you set this environment parameter to true. And that's something handy because then you control who can make requests against this remote schema via Hasura. If we go back over to the API to issue queries and such, you'll notice that I have the hello world function down here now that is available on the Hasura GraphQL API server that will make a call against that other remote schema GraphQL endpoint. So if I run this query now, which is against the remote Azure function, we ask for the hello function, we will get the response from that function, which I just did right here. So now that consolidates all of your GraphQL endpoints into this one GraphQL endpoint. So you've got all your federated pieces available via this endpoint. Makes it much easier to work with, makes it easy to bring together your various things. And then for anything that you need to build outside within Azure itself, like if you need to set up an Azure Functions project or even some other type of tertiary system, you can bring it together like this using remote schemas. So this is all running in Azure. I'm looking at localhost, but if I went out to the actual console in Azure, it'd be running because this is actually pointing here, right? This is the URL. Matter of fact, let's do this, and then I'll do that. There we go. So that's running on the actual server. I left in the configuration in the Terraform for the environment variable to leave this active. So if you went out right now to that endpoint, post in the comments, so you can click on it. If you go to that endpoint, you can actually go to the console and check out the data, query against the data, mutate the data, do whatever you want because it's wide open. Deployed that so that it would be wide open to make it a very straightforward example. If you got any questions or comments, please let me know. Happy to answer questions and comments. All right, so that's all in there. Let's make it available. A few extra little things here. Adding the last few elements live. There we go. And then what's our thing? Okay. So let me get out to GitHub here. And do I have that? Oh, let's create it. Oops. Oh, give me just a second. There it is. So this is what I'm doing. I'm going to create this, and we'll call it Azure Functions Single Project Example. Here we go. We'll do that. Serverless project example. Now I'm going to make a few more changes to this project over time. I'm going to actually switch this out to a Node.js project. But what's great is you'll be able to bookmark this specific repo, and then all the changes I will get into this repo. So you'll have the most up-to-date, operative, working repo that you can have. So there we go. This is a repository. Can I just add this instead of branch? Yeah. There we go. So I should just be able to paste that in. There we go. Hey, made it simple for me. All right, so now out yonder here, you've now got a repo that you can go check out. And again, I will post that in the comments so it's clickable. Check it out. Give me a little star up here. I'll add a README right now. I'll just say documentation is on order and being built. All right. There we go. So any questions, any comments? I am going to call it complete and shipped at the moment. Like I said, there will be a few more tweaks and such as I shift this out to a Node.js function project that will still include this infrastructure directory, which is kind of the key part. And I intend to also add the other awesome nugget, which will be the things you need in Terraform to actually deploy the Azure function from this repo. So that is my goal. That'll be added in there over the coming days, and it'll basically deploy what we just looked at. It'll have the metadata, it'll have everything else. So when you deploy it, it'll actually be mapped to the hello world function on the Azure Function GraphQL server. There's a lot of functions, a lot of nested function going on there. And you'll be able to use that as a reference application to start your own Azure functions and build from that however you'd like. If there's other capabilities, other functionality that you would like to see added to that repo, that would make it more useful to you, let me know. Let me know in the comments below this video, which will also be on YouTube as soon as we set it up to the VOD. And also, as a quick reminder, check out the Enterprise conference coming up. I thought I had the slides for that, but I don't think I do. So we'll just look it up. Hasura Enterprise Conf 2021. So this is what's coming up right here. So this is the website. You can get out there. You can register. Easy peasy. It's free. It's virtual. So do attend. Get out there. Check it out. A lot of good stuff. There are some workshops. We got the talks listed, etc. So hope to see you there. In the meantime, everybody, happy coding. Have yourself a most excellent day.